All right. Well, hello and welcome. Thanks for being here. Welcome back to school. It's a little strange having your first day of class on a Friday, but it's because we have Thanksgiving Thursday and Friday off. So I guess to make sure that we get all 30 class sessions in, 30-ish class sessions in, we meet today. Um, okay. Well, my name is Miles Chen, and I'll be your teacher. Um, a lot of you I've had as students before, and it's good to see your faces again. And some of you, this is your first class with me, and so welcome. And I hope we have a good class together. Okay, let's talk syllabus stuff. And so it's the class is now published on Brew and Learn, and so you can go find the syllabus in the course information module. Homework 0 is your first assignment, I guess, and that's to kind of go over the syllabus. And my syllabus is 9 pages long. Well, it includes a table of contents now, so you can find your stuff. But anyway, I guess we'll go over it. So. Okay, I'll talk about a little bit more about what this class is about. We meet here. We've got you have found the classroom, and that's great. I would not consider myself a morning person. However, it seems every quarter I get assigned the 8 a.m. class because they always ask me, are you willing to teach at 8 a.m.? And I always say, yes, I'm willing to. And I guess I'm the only one who's foolish enough to say, yes, I'm willing to do it because I keep getting assigned 8 a.m. And it's fine. I mean, like if you take like all morning classes, like your day is done quite early in the day and you get to enjoy the rest of your day doing homework or something. But anyway, this is what we have. I will have office hours. The plan is 6 days a week. If I can't sustain doing office hours 6 days a week, then maybe I'll make an adjustment. But I'm on campus Monday, Wednesday, Friday, and I teach this class at 8 a.m. I teach Stats 21 at 9 a.m. And I'll have office hours, I guess, from 10:30 to 11:30, Monday, Wednesday, Friday. So if you have any issues, come see me during office hours. And I intentionally staggered it at 10:30, just in case you have a class at 10, then you can come at 11. Or if you have a class at 11, you can come at 10:30. So my hope is, I don't know, I guess if you have a class both at 10 and 11, then maybe that's an issue. But hopefully not all of you have that. And then I'll have office hours on Tuesdays and Thursdays, also staggered 4:30 to 5:30. And those ones will just be online only. So sign into Zoom. I'll be signed in. You can ask. And office hours is truly like the best way to get a hold of me. You can send me an email, but I'm slow at responding to emails, and it's not just yeah. So if you have kind of questions, issues, come see me during office hours. If you need to speak privately about something, I can always set up a breakout room on Zoom, or in person. We can always kind of close the door and speak privately. So that's fine. And so anyway, that's office hours. So Monday, Tuesday, Wednesday, Thursday, Friday, right there, and then I'll also have office hours on Saturday mornings at 10 a.m. And that uses a different Zoom link. I gotta fix that. I think it's correct on the other thing. And then there will be a few days where I'm not gonna have office hours. But that's that. Okay, list of topics. I'll get into that in a little bit. This is the plan, and I might regret this later, but this is what I've done. Well, I guess we'll have 3 exams. We'll have 2 midterms and a final, and it will be the final will be during 10th week. So it'll be 10th week Friday, because I think the originally scheduled was like finals week Friday, and I didn't want to do that. So we have I get a little bit of freedom. I get to pick. So I said, all right, we'll do it. We'll do 10th week Friday, and I hope that's okay. So we'll have our final exam 10th week Friday, and then plus it's class time, so then I got to write a shorter final that'll fit within the 50 minutes. So I figured win-win-win for everybody. Although, but that, yeah, I'm like, okay, well, to fit everything, I'll probably need 3 exams. So I'm just gonna have more grading to do, but that's the plan. Midterm 1, midterm 2, and a final. That's what we have. Okay. Grade scope will, I hope this link is correct. Okay, well, I don't want to log in. So you'll submit your homeworks on Gradescope, and there's a Campus Wire. Oh, I have to send invitations to Campus Wire. I'm sorry, I haven't done that yet. Okay, but we'll do that. Okay, our textbooks. These are our textbooks, and they should work if you're logged in from the UCLA. If you're logged in right now, and you go to the website, it should say brought to you by the UCLA Library, and you should be able to download the entire textbook, okay? And if you are at home, access provided by California Digital Library, download the book PDF. You should be able to get it. You have to either be on campus, or if you're at home, you have to VPN to the UCLA VPN, so it knows that you're, I don't know, part of the university, and that will give you access to the books. So I guess, quote, free, but not really, because you're paying tuition, and it's your tuition money that funds the UCLA Library, which is like the greatest resource that you have access to that I feel like students don't fully take advantage of. But you know, your tuition money pays for all sorts of things, my salary included, but also the library, and then the library gives you access to a bunch of stuff. And so, so yes, these books are available to you. Okay, this is how we're going to do our grading. I've got lecture view quizzes, and if you've taken a class with me before, you're familiar with those, and if you've not, I'll explain. It's pretty straightforward. We've got homework assignments. I'm planning on 5, maybe 6 assignments that will total up to 30%. So, and then none are dropped. So make sure you do them. Make sure you submit them. And then we have 3 exams, and they'll all each be worth, I guess, 18%. It's a little bit of an arbitrary number, but it's just so everything adds up to 100%. And so they're all equally weighted. And that's what we have, and then we'll have Campus Wire for 4% of your grade. Okay. Pretty straight scale for grading. Okay. Let's see. Lecture view quizzes, homework. Okay. So here's the thing regarding homework. Make sure you read your homework output. Okay. Make sure. So. If you click knit on your homework or render, you render your homework and there's like all these errors and the output's not there, we can't give you points, okay? We read the output and we grade the output, and so make sure your output is there, okay? An example that I have here is like, this is not a homework problem, but if the homework problem said like do a Fibonacci sequence and you write the code, this technically does produce a Fibonacci sequence in X, but the output's not there. So, and the graders don't have time to like copy and paste your code and run it themselves. They're just gonna be looking for the output. And so if you don't include this, we can't give you points for this submission. You need to just include something like print X to make sure it appears, okay? If it says make a plot or it says do this, make sure that output is visible. And then, when you submit on Gradescope, make sure you tag your pages properly, okay? Okay. All right, you can read all of this stuff on your own time. That's pretty much that. Okay. I don't know. Any questions, I guess, regarding course policies. I think we're okay. Okay, so what is this class about? Oh, I'm sorry. Let me talk about the lecture view quiz. So I guess instead of attendance, I'll be running lecture viewing quizzes, and it will look like it'll be 3 questions generally, maybe 4, or I don't know, a few questions. There'll be multiple choice, and I will just give you the answers in class. And so, for example, this very first question, the answer is E. Okay, E as an elephant. And I think what I'm gonna do is I will give you like 2 of the answers in the video, and then 1 of the answers will be only given to those who come in person. Okay, and so that's like just a little extra motivation to get you in the seat at 8 a.m. So you'll still get most of your points. Like if you're like 8 a.m. is too early and I don't want to come, I'll just watch the video. That's fine, and you'll get most of your points, but not 100%. Okay, and I think that'll be like the compromise thing. All right. So anyway, first answer is E. I'll give you answers to questions 2 and 3 later, but maybe just one of the questions for those who are watching the video there. Okay. So that's what we have. Okay, and just make sure you submit the quizzes close before the next class. All right. What is this class about? So this class is titled Monte Carlo Methods, and in my opinion, it's a really great class. I mean, here I am tooting my own horn. I think it's fun. I think you know, it's great for someone like me who I think I just enjoy kind of like coding up answers and things like that. So big picture idea, Monte Carlo methods, basically we use random sampling, and the computer is able to generate random numbers for us, and we use that to kind of estimate a numeric answer to a problem that might be difficult to answer analytically. Okay, we did a tiny bit of this, or at least if you took 102A with me, we did some bootstrap resampling and also randomization tests, and that's a form of a Monte Carlo method. Did anyone not do bootstrap or randomization tests? I think you're supposed to do it in 102A. But anyway, so it's the kind of idea that like you just resample your data, or you generate some random things, and you're able to kind of do a hypothesis test, or at least get some kind of estimate to some kind of answer that's difficult. So anyway, that's Monte Carlo methods. It was actually invented by this man Stanislaw Ulam. It was from during the Manhattan Project. Okay, so they were working on the atomic bomb and Los Alamos, and there was basically some calculations that the scientists were having trouble with, and they couldn't work out the math, and this man Stanislaw, he was kind of inspired by playing the game Solitaire, and he was kind of just questioning like what percentage of these games are winnable, right? Sometimes you play Solitaire, and sometimes the hand you're dealt, it's impossible to win. And he's thinking like, doing the actual math of trying to deal with the card deck would be hard. So an easier method might be to just try playing 100 different or a bunch of different random games, and just kind of keeping track of what percentage does he win. And that might be kind of give us an estimate of what percentage of games are winnable. And basically, they took this kind of concept and they said, well, can we just do some randomization? They programmed it onto like the old vacuum tube mainframe computer, like these giant room-sized things, and they did it, and it was, everything was super top secret, and so they had a code name. It was Monte Carlo, based off basically the casino in Monaco and things like that. So anyway, that's beside the point. Anyway, I don't know. Everyone's favorite class is Stats 100B, right? Did you guys take it with Professor Christo, or I don't know, who did you take your mathematical statistics class with? It's, I think, I don't know. It's an interesting class, but it's also a tough class, right? Because you have to do all of these integrals and things. And I don't know, maybe you guys love doing integration, but but it can be tricky, right? And so if you have just some random variable x, you've got this PDF, how do you figure out your expected value? You do the integral of x times f of x dx, right? So you take the integral of this. This is how you find your expected value, your mean, okay? Great, okay? And if it's discrete, what do? You take the sum instead, and you just sum over all of the possible values of x. That's how you calculate your mean. How do you calculate your variance? Basically, same kind of thing. You take the difference between x and your mu, and you integrate across all the possible values there. With you can also kind of recalculate it this way, doing expected value of x squared minus expected value of x quantity squared and things like that. Same kind of idea when you extend it to a discrete variable. All right, so that's what we have. You can also kind of take any kind of arbitrary function and throw it in there as well. So you could say, hey, if I apply this function to a random variable, what would the expected value be? So for example, if you have a normal distribution, right? So let's say z comes from the normal distribution, and then you say, I'm going to take whatever number I get and I'm going to square it, okay? And then I want to know what's the distribution of that, okay? And then what's the mean of that thing? You would do this kind of calculation, right? You'd plug it in, and we have that, right? So and you see, if you take what do you get? If you take if z comes from a normal distribution and then you square it, what's the distribution that you get? Chi-squared, right? Chi-squared with 1 degree of freedom, and then chi-squared with however many more degrees of freedom is like the sum of multiple of these things and stuff. And what's the mean of a chi-squared distribution? Well, you can do the integral, or I guess all of these things, right? So in a lot of these things, sometimes you're in a situation where that integral or that sum or whatever it is you're dealing with, sometimes it's too complicated to do it analytically, okay? And so instead of trying to get the analytic answer, instead of trying to actually do the integral itself, a lot of times we just say, hey, you know what? I just want to get an estimate to get something kind of close enough, okay? And a lot of times that's fine, okay? On the computer, we're like excited to get like 16 places of decimal precision, but in real life, you probably don't need much more than a few places of decimal precision, okay? Because if you think about like, what is your age? If I say, how old are you? You just give me a whole number, right? But really, you might have, and if you think of like, okay, I don't know, like 3 decimal places, like if you say I'm 22.147 years old, that's like the difference between one day and the next day or something, okay? And that's 3 decimal places. And if you were going to give me like a 4th decimal place of precision for your age or something, now we're talking about like your age over the course of like like minutes and hours, and so you would need to know like the exact time of your birth in order for it to be precise up to like four decimal places or something. So it doesn't. We often don't need as many decimal places of precision. Okay, it's important for like GPS and stuff, but not general day-to-day life things. Okay, so anyway, we want to get some kind of answer. So we can estimate the mean of a random variable. One way to do this is if you have a way to generate random values from f of x, you just generate a bunch of random values, and then you calculate the mean of those random values that you generated. All right, and so your estimate of your mean is you just take your random values, you add them up, divide by how many you have, and there's your estimated mean. Okay, so if you're unfamiliar with the distribution and it's just kind of producing random values, just take the mean of what you have, and that will serve as your estimated mean, right? And I think that makes intuitive sense, right? Oftentimes you get a data set. We're assuming the data that you have comes from some random process, and I say, hey, what's a reasonable estimate of the mean of this population? Well, you just take the mean of your sample, and you say, well, this has got to be a reasonable estimate for the mean of the population. And the same kind of idea here applies in that we're drawing random values from our distribution, and we're calculating the mean there. Okay? All right. What if I ask you this question? What is the mean of a chi-squared random variable with 5 degrees of freedom? Okay? And so now you're like going through the archive in your brain, and I don't know. I don't know if anybody knows off the top of their head. Probably not, or I don't know. Maybe some of you do, but probably you're gonna have to be like, okay, I'm gonna have to go on the internet, go to Google, and look this up. Go on Wikipedia, and so we would go to. Oh, my link doesn't work. We go Wikipedia, chi-squared distribution. All right, and then we go, okay, here's our PDF, the mean. Okay, so if it's 5 degrees of freedom, our mean is going to be 5. Like, oh, okay, that was simple enough. Here's our PDF, and you're like, oh yeah, that gamma function or whatever. And I'm not going to test you, but like kind of the analytic method to say, hey, what is the mean of this? You have a few different approaches. Trying to take the integral of this is kind of tough. So another way to do it is you would use the moment generating function. That was like, we had fun with that, right? And so the mean is equal to the first moment, which is the first derivative of the moment generating function, and you do all of this and you evaluate and you get k. Okay, so if you have k degrees of freedom, 5 degrees of freedom, your mean is going to be your k. Okay, here's another approach, and this is the Monte Carlo approach, and this is very easy. Okay, you just start up R, and we have a function r chi-squared. Okay, r chi-squared gives me random values from the chi-squared distribution. So I say, hey, give me 100,000 10 to the 5 random values from the chi-squared distribution with 5 degrees of freedom. And then that forms my sample. I've got 100,000 values, and then I say, all right, what is the mean of those 100,000 values? And I get 4.993. And so, the analytic answer is 5. And my Monte Carlo estimate, which required no real understanding of any of the math. I don't even need to know what the chi-square distribution looks like. I just needed to know that, like, I have a way to generate random values from the chi-square distribution. I could just do this, and I get an answer. Okay, and that's that. And this is basically what we're going to do. We'll just do it slightly more more complicated stuff, okay? What's the variance of a chi-square distribution with 5 degrees of freedom, okay? Well, again, we could go the analytic way. You could look things up in on Wikipedia, and some of these things are nicely defined. So the variance is just 2k. We could go through and do the analytic approach, okay, using the moment generating function or whatever. Monte Carlo method, well, we already have our sample of 100,000 values. So I'm going to just say, hey, what's the variance of all of those things? And I get 9.978, okay? Analytic answer is 10. I'm getting something pretty close, okay? I'm getting something pretty close. And so so that's that. We're getting an estimate, and we just say, hey, this is good enough, and we go about our day, okay? And so that's where we're headed, okay? And so these Monte Carlo methods are very useful in the context of Bayesian statistics, because in Bayesian statistics, we frequently end up with big and messy integrals. Have any of you done Bayesian statistics? I'm imagining most of you have not, okay? And so I will introduce the concepts of Bayesian statistics, I guess, during our first week, okay? So on Monday, I'll introduce you to Bayesian stats. If some of you have already done Bayesian stats, then it will be review. But I imagine for most of you, it will be kind of your first time, and that's I don't know. I like Bayesian stats. Yeah, I'm not. I don't know. There's sometimes like I don't know, a rivalry between Bayesian and frequentist statistics, and intro stats is almost always taught from a frequentist perspective, and then later on we teach you Bayesian stats. I think both are great. So, but anyway, in Bayesian stats, you often end up with these big and messy integrals that are like too hard to calculate or too hard to solve analytically. So, so we use Monte Carlo methods to get our answers, okay? Also, you have these very kind of high-dimensional problems, and again, doing the math in those cases gets real messy. So Monte Carlo methods also very useful there, okay? And so we can do these random simulations, produce estimates, and we don't have to do these impossible or just really tough problems. All right, so this is kind of our list of topics that we're planning. So we're going to do some core concepts of Bayesian stats, and then we'll do things with R's built-in random number generators, and then sometimes we're in situations where we don't have a random number generator and we need to generate random values ourselves, and so we'll do that. And then a lot of Monte Carlo methods depend on using a Markov chain, so we've got to talk about what Markov chains are in those cases, and then from there we'll work on it. We'll work our way to kind of these two important sampling methods, the Metropolis algorithm and the Gibbs sampler. And so this is just a real kind of introduction to Monte Carlo methods. There's certainly even more that can be done, but this will take up our 10 weeks here. All right, let me give you your second view quiz answer, and that is the letter B. B as in bear. B as in bear is your second view quiz answer. Okay, if you've taken a class with me before, you're going to hear this same spiel. I've given this spiel before. I give this to like every class, so you'll hear it again. Just bear with me. It's become even all the more important now that we have AI that can like do all of our homework for us. Okay, so the truth is that for all of the homework that I assign you and things like that, you could probably find the answers, okay, online. And if you can't find it online, you could probably ask ChatGPT, give the problem, and say, hey, do this homework for me, and it'll probably do it, okay? And I don't know, I'm not sure. I don't know what the future is going to look like, okay? And I don't know if I don't know how like what's going to happen, right? Right now, I'm still a believer and an optimist that like I'm teaching you useful and important things, and this is going to be like good for you, and that like we're not going to all be replaced by AIs and things like that, okay? But yeah, certainly some menial tasks might be replaced by AI and things like that, and every time OpenAI or what are these, they release the latest model of their thing, it is like better and better and is getting better at like reasoning and thinking. I don't know. It's like there's. I don't want to say it's sentient, but I feel like it is able to make like it's very impressive. I will just say it's very, very impressive, where I feel like, ooh, maybe it is capable of doing some kind of thinking there. But anyway, besides the point, you guys are here to learn, I hope, okay? And that it's not just you're here to, get this paper degree at the end. I do think you actually do want to learn the stuff. And so I'm a true believer in that in order for your brains to grow, you have to challenge it, okay? And we understand this very much when it comes to things like working out and practicing a sport or practicing music or anything like that. You have to like kind of put yourself through the paces. You have to experience a little bit of pain to experience some gain, right? And the same thing goes on with your head. With your brain, if you don't challenge it at all, your brain's not going to go through extra work and become like form new neural connections to if it doesn't need to, right? But if you face yourself with a homework problem and it's hard and your brain has to work really hard, then when you go to sleep, your brain's going to say, all right, we need to form some new connections so that this task that we're working on gets easier, right? And then so like when something clicks in the future or as you're learning, that's because your brain has formed these new connections and you're able to do that. And so you have to kind of put your brain through that challenge for it to say, all right, it's worth it to form these extra connections, okay? And so that's how it's going to be. So my hope is that the homework assignments that I've written are of an appropriate difficulty and challenge, where it will challenge you. It's not intended to be overwhelming, but it will force you to kind of have to think through and wrestle with it and get to the answer. Okay. If you get stuck and you're like, I just want to copy someone else's work, or I just want to ask the AI to solve it for you, you're basically taking away that opportunity for you to kind of exercise through it, right? It's like going to the gym, saying, man, these weights are heavy to lift. I'm going to ask somebody else to lift the weights for me, right? And if somebody else lifts the weights for you, you can't then clap and say, oh, we had a great workout, right? Because the whole point was for you to lift those weights yourself, okay? The point of going to the gym isn't so that you could say, hey, weights got lifted up off the ground, but the whole point is that you yourself are lifting the weights. And that's the whole point of the homework, okay? I like doing the lecture and I like that you're here, but the true learning is going to happen not here in the classroom, okay? The true learning is going to happen when you go out and you try doing these assignments and you try doing the exercises yourself. So yeah, going to the gym and having someone else lift the weights for you, that's not going to help. Doing the homework and having ChatGPT answer the questions for you, also not going to help, okay? Again, if you feel tempted to kind of, take the easy way out here, I just want to kind of appeal to you and remind you that the whole point of this journey and this stuff is for you to learn. Okay, so the goal of the course isn't, of course we want to get good grades, but that's not the goal. Okay, the goal isn't that we just have the homework done and we turn it in. Okay, the goal is that by you doing it, you learn. Okay. I'm gonna give my spiel on grades and life now. Okay. So you guys are here at UCLA. This is probably your fourth year for most of you, and you got into UCLA because you had good grades, and certainly all of your, not all of your waking hours, but a lot of it is spent in school doing school-related things, and so grades feel super important, and I get that because I was a student too, and I still remember, even though it's been decades now, I still remember what it felt like. And I'm able to say this now that I'm like far removed from this, but your grades do not define you. Okay, it feels good to get good grades, right? It feels, there's something very rewarding about like studying, and then you take that exam and you feel like I did good, and then you get your grade back and you got a good grade and you're like, yes, like this, it feels good. And then when you get a bad grade, that feels terrible. But that said, once you're like graduated and removed from being enrolled in school, I don't think I've encountered anybody who looks back and was like, oh man, I wish I wish I worked harder to go from an A- to an A, or a B+ to an A, or something like that. Okay, if somebody has regrets about school, it's because they like did nothing and got all F's. Okay, and then they say like, I wish I tried harder in school. But it's not going to be somebody who was battling between a B+ and an A- or an A or something like that. So that's not. I don't think that's going to be the struggle that you'll look back. Okay, a lot of times if people look back on how, with regret on how they spent their time, it'll be like that they didn't invest in other people. I think that's kind of a more common regret. As far as achieving a work-life balance, I like to think and say that in life there are kind of three broad categories where we could put our time and our energy. And just broadly speaking, I say we have work, we have relationships, and we have ourself, right? And then so work includes actual job and internships and stuff like that, but I also put school and studying and academics into the category of work, and any other kind of professional obligations that goes there. And then relationships is basically how we interact with other people, and so that's going to be your family, your friends. If you're in a romantic relationship, it includes that. Any other kind of social obligations goes there. And then yourself, okay? And this self is going to be taking care of your physical health, your mental health, your spiritual health, all of that. And the bottom line is there's only 24 hours in a day. There's only 24 hours in a day, and you have to kind of tend to all of these different categories. And it's impossible to do 100% for everything, okay? It's impossible to give 100% to all of these things. So I argue that work-life balance and kind of being satisfied with your work-life balance is achieved by you making conscious decisions about what's important to you, and then you devote your time and energies accordingly. In general, and what we want is that the more time you put into a certain category, the more you're going to get out of that, right? And basically, when you say this is less of a priority and I'm not going to put in as much time and energy into here, the natural consequence of that is that aspect of your life is not going to flourish as much, okay? And And if you can say, well, yeah, I made a decision, and I said I'm not going to put as much time and energy into it, and I am okay with this part of my life not flourishing, kind of dwindling a little bit. Then I feel like then we can kind of be satisfied and happy, right? If you feel like I need this part of my life to flourish and this part, and I need all aspects of my life to be running at 100%, you're going to find yourself stretched too thin. You're not going to be able to tend to everything, and then you'll feel like you'll get burned out. And so I think we just have to kind of make conscious decisions and recognize like who we are and our own kind of limitations, and like how much time we need to dedicate to ourselves and things like that, and say, if I want to take care of these things, that means this part of my life I can't put as much time in, and if you can say, all right, I'm not putting as much time in there, this part's not going to flourish as much, I think we can have a good work-life balance. Okay. A silly example is like just even within the relationships category, you could put your time into like friends, you could put time into a relationship with a romantic partner, and sometimes there's like a noticeable change, right? If you start off with a group of friends, and then one day you get involved in a romantic relationship, you might find that originally you spend a lot of time with your friends, and now you're spending a lot of time with your romantic partner, and now you have less time with your kind of original group of friends. And the natural thing that's going to happen is you're not going to be as close as you were to your friends, and you will get closer to your romantic partner. Okay, and that's fine. It might come to a point where, I don't know, your original group of friends go off and decide to do something, and they don't include you. All right, and that's not necessarily like they're being vindictive and jealous of you or something like that. It's just you started spending less time with them, so oh, that's really loud. You started spending less time with them, so you're not as close, and that's okay. And this, I mean, this is kind of what's happened in my own life, in that like now I have a family, I've got children, and I spend a lot of time at home, and I don't have as much time as I used to like hang out with my friends. And so there's no bad blood or anything, but I'm just not as close. All right, I don't we don't go out to movies or baseball games or anything like that as much as before. And so still friends, but just we're not up in we don't know everything that's happening in our daily lives and things like that. And that's okay. I'm okay with how relationship dynamics have changed over time. And the important thing is that you as a person, you get to choose what's important to you, and you get to choose where you want to spend your time. Okay, and so if you can kind of accept the natural consequence of just you invest less time into something, and you're gonna get a little bit less out of that, you'll I think you can go through life without bitterness or jealousy or things like that. Similarly, like at work, there you'll have different phases in your life where you'll say, you know what, it's really important for me to make advances, in my career. Okay, and so that means like you might be spending a lot of time at work. Okay, and if you're spending a lot of time at work, you might have not as much time for relationships or friends or things like that, and that's okay. That's fine. And the consequence of that, we hope, is that you will advance in your career, and not that we're hoping for your friendships to dwindle, but that's what could happen. Now, on the other hand, if you say, it's important for me to maintain my friendships and relationships and things like that, and I'm not going to spend as much time at work, that might mean somebody else who's at work all the time, they might get promoted before you do. Okay, and that's just how things go. All right, but you get to choose. You get to choose which of these priorities are more important. And so, earlier I said I'm not great at responding to emails. And that's because I've made a conscious decision to, because if I said responding to emails is really important to me or something, it would take up a lot of time of my day. And I said, you know what, I am okay with not being great at responding to emails, and it's something that consistently comes up in like my course evaluations, that students complain that I took forever to respond to emails. And I said I'm okay with that, and so I'm trying to compensate by having a bunch of office hours instead, so you can kind of get your communication and things like that. But I've made a conscious decision that I want to make sure that I have time for my family and other things that I enjoy, and I don't want my whole day spent responding to emails and things like that. So you get to make choices, and I've made choices. Okay. Taking care of yourself is important, and this is not just some platitude that I say. Self-care is important. There's other professors in the department that also kind of want to emphasize taking care of yourself, and this is not just something we say just to kind of sound nice and friendly. Okay, I genuinely mean it, right? And what this means is I want you to be okay with the decision and say that, like, I need to take a break. I need to make sure I get enough sleep tonight, right? And by making this choice of taking care of myself, that might mean I'm not going to finish my homework, okay? I'm not going to finish my homework to 100%. And I'm going to just do this. I struggled with this last thing, and I'm not going to do this last problem, okay? The consequence of that is you're not going to get 100% on your homework, right? Like if you leave half of your homework undone, you'll get half of the points, okay? But I want you to be at a point where you can say, I am okay with this decision. I'm okay with not completing my homework to 100%, and I'm okay with losing the points, because in this moment in time, taking care of myself, or being a good friend or something, is more important. And so that's what we mean when we say self-care is important. Okay. If you don't take care of yourself, oftentimes you suffer from either physical health problems or mental health problems, and it's tough. Okay, so do that, right? So sometimes this means choosing not to complete your homework to 100%. The natural consequence is a homework grade that's going to be less than 100%. But if you can kind of embrace this and say, hey, I made a choice, and I'm okay with the consequences of my choices, I feel like we can be okay. All right. The last slide, I am all for having fun and entertaining activities and things like that. There is a category of activity, though, that I would say is unproductive and fruitless, and I think it just requires you to be kind of aware of this and make choices accordingly. Basically, there's like a whole category of apps and games that are not designed to make your life better, but they're just designed to increase engagement with the app. Okay? And when you engage in this app or whatever game or whatever it might be, your brain gets these tiny little dopamine hits, and that's why you keep saying, like, okay, I just want to scroll to the next thing, I just want to kind of swipe to the next video or whatever. And it's fun in the moment, but once you're done, you don't necessarily actually feel any better, right? I believe that entertainment and having fun is truly important, and I think they should be activities that after you participate in it, you walk away and you feel better. You feel like I love life, and life is great, and you want to be able to hang out with your friends and say, hey, that was fun, I want to do this again. Okay, versus I think some of these apps and websites, and it's easy to just kind of scroll infinitely and then you're done and you're just like, oh man, I wasted like 3 hours and I don't know. So anyway, just be aware of that, okay? And budget your time accordingly. Okay, I'm gonna end the video and then let me give